So we are going to factor now a polynomial multivariate one. So if I have 26 and 6, their greatest common factor would be 2, right? I have a u to the 9th and a u to the 3rd, so I would use the lower one, the u to the 3rd. I have an x to the 8th and an x to the 8th, which are the same thing. And although the one has a w, the other one doesn't, so it doesn't have those in common. So 2u to the 3rd x to the 8th should be your greatest common factor. So if I take 26u to the 9th x to the 8th and I divide out the 2u to the 3rd x to the 8th, I'm left with 13u to the 6th. Plus, if I take my 6u to the 3rd w to the 5th x to the 8th and I divide out my 2u to the 3rd x to the 8th, I'm left with 3w to the 5th. So again, these shouldn't have anything left as a common factor when you're done if you have it factored all the way. Number 5 there, my greatest common factor would be what? Seven. X. Y to the 3rd. 7xy cubed. And so if I divide out the 7xy cubed on my first term, I'm going to have just the u to the 4th left. And on my negative 28xy to the 6th, I would have u to the 4th minus 4y cubed left when I take out the 7xy cubed. And number 6, if I take out my greatest common factor there, my greatest common factor of 30 and 12. 6. And then with my variables, I can take out 3 to the 3rd and x squared. So I'm left with 5 for my first term.
Minus 2. E
to the 4th and w to the 7th. So again, we subtracted the exponents, didn't leave us any variables here. Here we had 4 left. That guy didn't take any of them out, and the x squared is gone.